Cedar Rapids, Iowa. 1975. An 81-year-old man sits in an office at Collins Radio, reviewing technical drawings under fluorescent light. Scale models of strange aircraft line the shelves, wingless shapes, delta forms, things that shouldn't fly. Outside the window, cornfields. Nothing about this scene says war. Nothing about this man says weapons designer. He holds 50 United States patents. His work shaped the future of supersonic flight. The delta wing on the Space Shuttle, that's his configuration. The Concorde, his principles. The F-106 Delta Dart that defended American skies for 20 years, his geometry, his life's work. His name appears on none of them. The aircraft he's remembered for carries another man's name. It was the fastest fighter of the Second World War. It climbed to 30,000 feet in 3 minutes. Its aerodynamics were flawless. The wing so sound that every supersonic fighter built in the next 50 years borrowed the same shape, and it killed more of its own pilots than enemy aircraft. His name was Alexander Lippisch, born November 2, 1894, in Munich. His father was a painter, a successful one. Franz Lippisch made his living with oils and canvas, and his son grew up believing the world was something you studied by looking at it. In 1909, when Alexander was 14, Orville Wright came to Berlin. Tempelhof Field, a flat expanse of grass and a man in a fragile machine circling overhead, and 50,000 people staring upward at something that shouldn't have been possible. Alexander was one of them. He brought a sketch pad. He painted what he saw a watercolor of Orville Wright's biplane against the Berlin sky. He kept that painting for the rest of his life. He never finished an engineering degree. He was an art student when the First War interrupted, and after the armistice, he never went back to a classroom. Everything he knew about aerodynamics, he taught himself in workshops. In wind tunnels, he improvised from barn equipment. In 14 years of building aircraft that other. Engineers called wrong. A painter's son who saw a plane fly and spent 67 years trying to build a better one. The wing was perfect. Everything else was a death sentence. The war that interrupted his education also gave him his obsession. Lippisch served in the German army as an aerial photographer, not a pilot, a passenger. He sat in the rear seat of reconnaissance aircraft, sketching maps of trenches from above, watching other men fly. And when the armistice came and the Treaty of Versailles dismantled German military aviation, Lippisch did something that seems obvious only in retrospect. He built gliders. Germany wasn't allowed to build military aircraft. The treaty saw to that: no armed planes, no combat engines, no air force. But a glider isn't an aircraft. A glider is a toy. The Allied Control Commission didn't care about toys. So across the Rhine Mountains in central Germany in the early 1920s, a generation of band engineers did the only thing they were permitted to do. They launched silent, engineless, weightless things from grassy hillsides with rubber bungee cords, and learned to fly in the one medium the treaty forgot to prohibit. Lippisch was among them. By 1925, he was director of glider research at the Rennes-Rossitten-Gesellschaft. 14 years of freedom, no corporate oversight, no military deadlines, no one looking over his shoulder. Just wind, canvas, and an artist's obsession with shapes. And the shapes he chose were wrong. Every other engineer built conventional tails. Lippisch threw the tail away. Swept wings. No vertical stabilizer. Forms that looked like errors on a drafting table but flew. By 1928, he'd built the world's first rocket-powered glider. By 1931, he was building pure delta wings, triangular, radical, unlike anything in the sky. The treaty that was supposed to prevent the next war had quietly created the aerodynamic foundation for its most radical weapon. And the man building that foundation had never finished engineering school. But the man who would build this weapon had never sat in the pilot's seat. and the fuel they would give him had never been put inside an aircraft with a human being. In 1937, the German Air Ministry noticed Lippisch's work. 14 years of gliders and deltas and shapes that shouldn't fly, and now the men who built the Luftwaffe wanted to know what happens when you strap a rocket engine to one of them. They called it Project X. The first prototype, the DF-194, flew under rocket power in August 1940. It worked. Not gracefully, the landing was rough, the engine unreliable, the fuel corrosive. But it worked. The tailless configuration that every conventional engineer had dismissed held together at speeds no piston-engined fighter could reach. By spring of 1941, the first true prototype, the ME-163A, was flying. And the man they chose to push it to its limit was a champion glider pilot named Heini Dittmar. Dittmar understood Lippisch's aircraft in a way that no conventionally trained pilot could, because he came from the same world silent flight, sailplane competitions. They ran slopes. He knew how a tailless glider behaved. He trusted its instincts. He said later it handled so naturally that a child could fly it. On October 2nd, 1941, Dittmar climbed into the cockpit. Takeoff. Engine ignition. The acceleration was unlike anything in aviation, not the gradual build of a piston engine, but a continuous, violent shove that pinned him to the seat and didn't stop. Airspeed past 700, past 800, past 900 kilometers per hour. Then the controls began to feel different. The air ahead of the aircraft stopped behaving like air and started behaving like something solid. Compressibility, a phenomenon that no pilot in history had experienced, because no pilot in history had flown this fast. He cut the engine. Silence. He glided back. 1,003.67 kilometers per hour. The fastest any human being had ever traveled in a powered aircraft. Faster than any Allied fighter. Faster than anything the Luftwaffe had. The speed was immediately classified. The FI never recognized it. Outside a handful of engineers and test pilots, no one knew. She was the famous one, Hanna Reitsch, the celebrity pilot, the woman who crashed an ME-163 in October 1942 and fractured her skull in 4 places and reportedly insisted on dictating her post-flight report before losing consciousness. Her name made the newspapers. Dittmar's name made a classified file. But it was Dittmar who mattered, because 1 month after becoming the fastest man alive, Heini Dittmar broke his spine. 5th thoracic vertebra. That's the one that cracked. November 1941, 1 month after he'd reached 1,000 kilometers per hour. Dittmar wasn't shot down. He wasn't caught in a structural failure. He landed. The ME-163 had no landing gear. That was the first decision. Lippisch's aircraft took off from a jettisonable wheeled dolly, a 2-wheeled cradle that dropped away the moment the plane left the ground. It saved 150 kilograms, weight that could be filled with fuel instead, which meant more seconds of powered flight, which meant more altitude, which meant more speed. The math was clean, but it meant the aircraft had to land on its belly, a retractable skid, steel on grass, at 220 kilometers per hour. No shock absorption. No suspension. No second approach if you misjudged. The impact traveled through the skid, through the airframe, through the seat, into the base of the pilot's spine. It happened on every landing. Not sometimes. Every time. The jolt was so consistent, so predictable, and so destructive that Luftwaffe flight surgeons gave it a name. They called it Komet Ricken, Komet spine. It had its own diagnosis because the aircraft broke backs often enough to warrant one. Dittmar's 5th thoracic vertebra, the fastest man alive, grounded for a year by a landing system that saved 150 kilograms. That was one decision. There were others. The tailless configuration, 15 years of glider research, applied to a rocket-powered interceptor. Lippisch knew how tailless aircraft behaved at 150 kilometers per hour. Nobody, including Lippisch, knew how they behaved at 900. Dittmar found out over Pinamende when the air turned solid. The configuration that felt like a sailplane at cruising speed became unpredictable at the edge of compressibility. But the data from that flight was classified. Future pilots wouldn't know what Dittmar had felt. The jettisonable dolly, if the dolly bounced after separation and struck the underside of the aircraft, it could rupture fuel lines. The fuel inside those lines was T-Stoff and C-Stoff hydrogen peroxide and a methanol-hydrazine mixture. They were hypergolic. They ignited on contact with each other. No spark required. No warning. A bouncing dolly didn't mean a rough takeoff. It meant a potential fireball at 60 meters altitude. And the fuel placement. T-Stoff in a tank directly behind the pilot's head, C-Stoff in a tank between the pilot's legs, fuel plumbing running through the cockpit, past the pilot's elbows, inches from his body. Two chemicals that ignite on contact with each other, separated by thin aluminum walls, stored on both sides of a man's body. Each of these was a deliberate choice. Each one saved weight. Each one added speed. And each one killed pilots. But Lippisch didn't make these decisions alone. On January 2, 1939, by order of the German Air Ministry, Alexander Lippisch and 12 of his engineers were transferred from the DF's Research Institute to the Messerschmitt company in Augsburg. It was not a collaboration. It was a forced marriage. Willy Messerschmitt didn't want Lippisch, didn't want his tailless obsession, didn't want a self-taught designer with no formal credentials working under his roof on a project he considered a distraction from the Bf-109, the aircraft that was actually winning the war. Lippisch was an experimenter. Messerschmitt was an industrialist. One man wanted to push boundaries. The other wanted to build proven machines in volume. They shared a building. They shared a project. They could not share a vision. It could not last. By 1943, the marriage was over. Willy Messerschmitt had what he needed, the airframe design, the delta wing data, the proof of concept. He didn't need the man who'd created them. The arguments had become daily. Lippisch wanted changes. Messerschmitt wanted production. The Air Ministry, tired of refereeing a war between two egos while an actual war was being lost, made a decision. They removed Lippisch. Not fired, not court-martialed. Transferred. In 1943, Alexander Lippisch was sent to the Aeronautical Research Institute in Vienna. His new assignment, the P-13A, a theoretical ramjet-powered delta-wing interceptor designed to burn coal as fuel. Coal. The man who built the fastest aircraft in the world was now drawing blueprints for a machine that would run on rocks. He was essentially exiled to a paper airplane factory. The Me-163 entered combat on July 28, 1944, a full year after Lippisch was removed. The pilots who flew it into battle had never met the man who designed it. The man who designed it had no authority over the modifications made after he left. Every fuel line routing, every cockpit adjustment, every operational procedure was someone else's decision now. But the fundamental architecture, the tailless delta, the belly skid, the placement of the fuel tanks around the pilot's body, that was all Lippisch. Those decisions were baked into the airframe like a signature. Every pilot who died in combat was flying a plane whose creator had already been kicked off the project. And the aircraft itself, the one that bore the designation Messerschmitt Me-163, carried the name of the man who had resented it from the start. Lippisch designed it. Messerschmitt didn't want it. But the records, the museums, the history books, they say Messerschmitt. The designer was erased. The man who fought against the project got the credit. The man who created it got Vienna and a coal-powered daydream. He was 49 years old. He had spent 20 years building toward this aircraft, and he would spend the next 30 years watching other people fly variations of his ideas while his name appeared nowhere on any of them. But the machine Alexander Lippisch built was about to meet its pilots, and its pilots were about to meet its fuel. None of that explains how it killed them. The biography is clean an art student, some gliders, a corporate feud, but the dying wasn't clean. The dying smelled like ozone and methanol. The dying sounded like a shriek that wasn't an engine and wasn't quite human. And the dying started with a clear, oily liquid that looked like water and behaved like acid. If you want to understand what Alexander Lippisch built, stop thinking about the man. Start thinking about the fuel. T-Stoff, 80% concentrated hydrogen peroxide. Clear, faintly oily, almost odorless in small quantities, a hint of ozone, nothing more. At room temperature, it looked harmless. You could mistake it for water. Ground crews did at first. Then they watched what it did to a leather flight glove. The leather turned white. Then it dissolved, not burning, oxidizing. The hydrogen peroxide broke down the proteins in the hide the way stomach acid breaks down food, except faster and without the courtesy of an enclosed space. It did the same thing to skin. They put this liquid inside an aircraft, 1,500 kilograms of it, in a fuselage shorter than a modern SUV, the smallest operational fighter of the Second World War. And then they added a second chemical, C-Stoff, a mixture of methanol and hydrazine hydrate. Toxic, corrosive, carcinogenic. On its own, C-Stoff would poison you. Mixed with T-Stoff, even a drop of one meeting a drop of the other, it ignited. Spontaneously. No spark. No ignition system required. The reaction was hypergolic. The chemicals were their own match. This was the Walter HWK 109-509A rocket engine. Not a jet, not a piston engine. A controlled chemical explosion that produced thrust by forcing two substances that wanted to destroy each other through a combustion chamber at enormous pressure. The sound it made was not the growl of a merlin or the whine of a turbine. It was a continuous, high-pitched, shriek superheated steam and decomposing peroxide screaming through exhaust nozzles at temperatures that would melt aluminum. Ground crews heard it from 2 miles away. Bomber crews heard it from 5,000 feet above. And it burned fuel at 4.5 kilograms per second. That number defined everything. 4.5 kilograms per second meant the aircraft carried enough fuel for 7.5 minutes of powered flight. 7.5 minutes to take off, climb to 30,000 feet, intercept a bomber formation, attack, and begin the descent. After 7.5 minutes, the engine died. Not sputtered, not faded. Died. One moment, the pilot was flying the fastest fighter in the world. The next, he was sitting in a silent glider at the edge of the stratosphere, with no power and no second chance. 30,000 feet in 3 minutes. That was the climb rate, 16,000 feet per minute, faster than anything the Allies had ever tracked on radar. A speck that appeared on the scope and reached altitude before the fighter controllers could scramble a response. By the time anyone reacted, the Me-163 was already above the bombers, already burning through the last of its fuel, already running out of time. The clock started the moment the engine lit. It never stopped. More than half the aircraft's weight at takeoff was fuel. 2,018 kilograms of T-Stoff and C-Stoff inside an airframe that weighed 4,110 kilograms fully loaded. The pilot wasn't riding in an aircraft that happened to carry dangerous fuel. He was riding inside a fuel tank that happened to have wings. And the fuel wasn't stored in some armored compartment beneath the floor. The T-Stoff tank sat directly behind the pilot's head, close enough that if he leaned back, His helmet rested against the bulkhead, separating his skull from 1,500 kilograms of concentrated hydrogen peroxide. The C-Stoff tank sat between his legs. Fuel lines ran through the cockpit walls, past his elbows, inches from his body on 3 sides. Imagine the geometry. You're sitting in a space barely wider than your shoulders. Behind you, a chemical that dissolves flesh. Between your knees, a chemical that poisons blood. On both sides, plumbing that carries both, separated from each other and from you by thin aluminum walls. If those walls crack, if turbulence shifts the airframe, if a hard landing jars a fitting loose, if a single connection fails, the two chemicals meet. And when they meet, they don't leak. They ignite. There was no direction a pilot could be thrown in a crash that wouldn't bring him into contact with one of them. The cockpit was tiny. The spring-loaded pilot seat, designed to cushion the belly skid landing, frequently failed to absorb enough of the impact. At 220 kilometers per hour on grass, the human body compressed in ways the seat couldn't fully compensate for. Comet's spine wasn't the only consequence of Lippisch's design decisions. It was just the one that left the pilot alive. The ones that didn't leave the pilot alive happened more often than anyone wanted to admit. Non-combat losses significantly exceeded combat losses. More than half of all Me-163 airframes were destroyed in accidents, not by Allied fighters, not by anti-aircraft fire, but by the aircraft's own fuel, its own landing system, its own engine failures. The fuel was more dangerous than the enemy. And there was one more problem, one that made all the others academic. The Me-163 was closing on B-17 bomber formations at a combined speed of roughly 340 miles per hour. At that speed, the pilot had approximately 2.5 seconds to aim, fire, and score enough hits to bring down a 4-engine heavy bomber before he overshot the formation. Entirely. 2.5 seconds. Then he was past it, and his fuel gauge was approaching 0. The plane was a weapon too fast to use its own weapons. On December 30th, 1943, at Bad Zwischenahn airfield in northern Germany, a test pilot named Josef Pohs walked to his aircraft. The airfield was flat, cold. December light, low and gray, across a landscape of grass and concrete, and the sharp chemical smell that never left the ground near an Me-163 dispersal area. Pohs was experienced. He knew the aircraft. He knew the fuel. He knew the procedures the hazmat-suited ground crews, the 2 fuel convoys approaching from opposite directions, never allowed within 800 meters of each other. He had done this before. Engine ignition. The Walter motor shrieked to life, that high, unnatural keening that wasn't quite mechanical and wasn't quite alive. Acceleration. The airfield blurred. The dolly dropped away from the belly of the aircraft and bounced, metal on metal. The dolly struck the underside of the fuselage as it tumbled. Somewhere in the gut of the aircraft, a fuel line cracked. The engine died. Silence. Pohs was a glider pilot now 60 meters off the ground, no power, too low to maneuver, too slow to climb. He tried to glide. The wing caught a radio antenna mast at the edge of the field. The aircraft cartwheeled a crumpling, tearing sound of aluminum and plywood, the airframe folding in on itself across 200 meters of wet grass. Then, stillness. The ground crew ran toward the wreckage. Among them was Wolfgang Spate, commander of Erprobungskommando 16, the unit tasked with proving the Komet could work. Spate was not a spectator. He was a friend. They couldn't reach Pohs. Not because of fire, not yet. The T-Stoff reached him first. 1,500 kilograms of concentrated hydrogen peroxide, released from ruptured tanks, finding its way through crumpled aluminum to the body of an unconscious man. The liquid that turned leather white did not behave differently with skin. It did not behave differently with muscle. It did not behave differently with the tissue of a man's face. Spate watched. There was nothing to do. The chemical process that had dissolved a flight glove in seconds was now operating on the body of his friend, and no amount of water or intervention could reverse an oxidation. Reaction that had already begun. Josef Pohs died on the grass at Bad Zwischenahn. Not from the impact, not from fire, from the fuel. Every design decision Alexander Lippisch had made, the dolly, the fuel placement, the hypergolic chemistry converged on that airfield in December 1943. The dolly bounced because it was jettisonable. The fuel reached the cockpit because it was stored around the pilot's body. The fuel dissolved the pilot because that is what 80% hydrogen peroxide does to organic tissue. Each decision had been made for rational engineering reasons. Each reason had been validated by weight calculations. And each calculation was now measured in a unit that doesn't appear on engineering drawings. Lippisch was in Vienna when it happened, 600 miles away, drawing coal-powered daydreams. He had been removed from the project 8 months earlier. He never designed the fuel system. He never chose T-Stoff. But he designed the airframe that stored it, the cockpit that surrounded the pilot with it, the landing system that failed often enough to release it. The architecture was his. The consequences fell on someone else. And the aircraft that killed Josef Pohs still carried the designation Messerschmitt Me 163. Not Lippisch, Messerschmitt. The man who designed it was gone. The man who resented it had his name on the wreckage. The man who died in it had neither man's protection. Pohs was not the first pilot the Me-163 killed. He would not be the last, but his death revealed something that the engineers already knew and the pilots were beginning to suspect. The aircraft's greatest enemy was not the Allies. It was itself. And yet, they kept flying it. To understand how a machine this lethal to its own pilots stayed operational, you have to understand the complete sequence, not the theory. The choreography. A single Me-163 sortie, from fueling to landing, in order. It began 45 minutes before takeoff. 2 convoys of fuel trucks, one carrying T-Stoff, the other carrying C-Stoff, approached the aircraft from opposite ends of the airfield. They were forbidden from coming within 800 meters of each other. The ground crews wore full-body protective suits, rubberized fabric, face shields, chemical-resistant gloves. The fuel lines from the previous mission had been flushed, drained, and cleaned. Every fitting was inspected. A single trace of T-Stoff residue in a C-Stoff line, a film thinner than a fingerprint, was enough to cause a detonation. The fueling took 30 to 45 minutes. The pre-flight took another 15. By the time the pilot climbed in, an hour had passed. He would be airborne for less than 30 minutes. He would be engaging the enemy for approximately 3 seconds. 3 seconds. That was the mission. Takeoff was 10 seconds long. The Walter engine ignited with that shrieking, inhuman sound, and the aircraft accelerated from 0 to 280 kilometers per hour in the length of a runway. The dolly dropped away. If it bounced, and it sometimes did, the sortie became a survival problem. If it separated cleanly, the pilot pulled back, and the Me-163 climbed. 81 meters per second. Straight up, the altimeter spinning so fast it was unreadable. 30,000 feet in 3 minutes. The fuel burning at 4.5 kilograms per second. The pilot had already consumed a quarter of his fuel just reaching altitude. At 30,000 feet, he leveled off and searched for the bombers. A B-17 formation, dozens of 4-engine aircraft in staggered boxes, each bristling with 13 machine guns, would be visible from miles away. The pilot turned toward them. He was closing at roughly 340 miles per hour, his speed plus the bomber's speed, converging. And here's where the math fell apart. The Me-163 carried two Mk-108 30mm cannons. Brutal weapons, each shell could blow a hole in a bomber's wing large enough to crawl through. But the Mk-108 had a muzzle velocity of only 540 meters per second. For an aircraft cannon, that was slow, and at the closing speed of a Komet attack, slow meant useless. At 340 miles per hour of closure, the pilot had a firing window of 2.5 seconds. In 2.5 seconds, he could squeeze off 8 to 12 rounds. To bring down a B-17, he needed 3 to 5 direct hits. The probability of achieving 3 to 5 hits out of 8 to 12 rounds at a combined closure speed of 550 kilometers per hour with a low velocity. Cannon was vanishingly small. Imagine it from the B-17 gunner's perspective. You're scanning the sky. You see a speck. The speck grows. It grows faster than anything you've ever seen, faster than a Messerschmitt 109, faster than a Focke-Wulf 190, faster than the recognition silhouettes on your briefing card. A keening whine rises Doppler shifting as it approaches. You swing your gun toward it. You squeeze the trigger. And it's gone. Past you. Behind you. 3 seconds, start to finish. Many gunners never got a shot off. Most Komet pilots never scored a hit. The plane was too fast to use its own weapons. That was the paradox Alexander Lippisch built into the airframe 20 years earlier when he decided that speed was everything. He was right, nothing could catch the Me-163. But he never solved the problem that speed created. At 900 kilometers per hour, you couldn't hit anything either. 7.5 minutes after takeoff, the engine died. The fuel was gone. Dead silence, not the fading drone of a piston engine winding down, but an instantaneous cessation. One moment. Thrust. The next, nothing. The pilot was now a glider pilot at 30,000 feet, descending at a steep angle, searching for his airfield below. He had one approach. One chance to line up on a grass strip that might be under attack. No power for a go-around. No fuel for a second pass. If he misjudged the approach, he landed in a field and hoped the belly skid didn't catch a furrow and flip him. Total mission time, 25 to 30 minutes. Time spent engaging the enemy, 3 seconds. That was the machine. That was what 45 minutes of fueling, an hour of preparation, and a lifetime of engineering produced. 3 seconds of combat and a prayer on the way down. And one man cracked the math. Feldwebel's Siegfried Schubert was a sergeant, not a commissioned officer, not a fighter ace with decades of experience. An NCO, a non-commissioned officer in his 20s, assigned to Jagdfaust 400, the only operational Me-163 unit. On August 24, 1944, Schubert launched into a B-17 formation over central Germany. He made his first pass. Hit. A B-17 heavy, 65,000 pounds of aircraft, 10 men aboard fell out of the formation. Schubert pulled around. He still had fuel. He made a second pass. Hit again. A second B-17 fell. 2 4-engine bombers destroyed in 5 minutes by a single pilot in an aircraft that gave him less than 3 seconds to fire per pass. It was the best day any Me-163 pilot would ever have. Schubert had just proven that the Komet could work, that one man, with enough skill, could overcome the 3-second window and the impossible math. Then, the plane killed him. Shortly after. That's the phrase the records use. Shortly after his best day, Siegfried Schubert climbed into the cockpit for a routine takeoff. The engine failed. The aircraft, still loaded with fuel, had no power and no altitude. It tipped forward, struck the ground, and somersaulted across the grass. The fuel did what the fuel always did. The Komet's best pilot was not shot down by a P-51. He was not caught in a bomber's crossfire. He was killed on his own runway by his own aircraft. Even the best pilot the Me-163 ever produced couldn't escape it. The first operational sortie had been July 28, 1944, near Merseburg. 5 Me-163s launched against a bomber formation. No confirmed kills. The bombers flew on. The Komets glided home. It was not a promising debut. By August, the unit was flying regularly. August 16th saw the first significant multi-aircraft engagement. Results were mixed, a few probables, a few claims, nothing decisive. The Allied escort fighters noticed something, though. The Komets were fast, untouchably fast during the powered phase. But after 7.5 minutes, the engine died. And then the fastest fighter in the world became the slowest. The Allies learned. They adapted. The counter-tactic was elegant in its simplicity. Wait for the glide. Escort fighters P-51 Mustangs mostly began orbiting Me-163 airfields at altitude. They didn't try to chase the Komets during the powered climb. They couldn't. Nothing could. Instead, they waited. 7.5 minutes. Then they dove on the powerless, descending gliders from above. A Komet in its unpowered descent was slower than a training aircraft. It had no engine to restart, no weapons worth firing at the closure speeds of the dive. It was, for a brief and fatal window, defenseless. The hunter became the prey in the time it took to burn through 450 kilograms of fuel. By early 1945, the program was collapsing. Not from a single cause, from everything at once. Fuel shortages. Allied bombing of the Me-163 airfields. Pilot attrition from the non-combat accidents that never stopped. The industrial base fracturing under strategic bombardment. By spring, operations had effectively ceased. 370 Me-163s were built. The confirmed kill total verified, cross-referenced, acknowledged by both German and Allied records, was 9. 9 enemy aircraft destroyed, 370 built, hundreds of pilots trained, thousands of tons of hypergolic fuel manufactured, specialized airfields constructed, hazmat infrastructure deployed. Furniture makers recruited to build the wings for 9 kills. Meanwhile, in Vienna, then in Preenam Chemsee, Alexander Lippisch waited out the last months of the war. When the Americans arrived, he was among the German scientists collected under Operation Paperclip. They flew him to Wright Field in Ohio. They tested his captured Me-163s. They interrogated him about delta wing aerodynamics. They were not interested in the rocket plane. They were interested in the wing. Lippisch answered their questions. He drew their diagrams. He consulted on their projects. He was cooperative, knowledgeable, and untroubled. He had been removed from the Komet program 2 years before it failed. Whatever happened to those pilots was someone else's problem now. The Me-163 Komet was not killed by the Allies. It was not killed by fuel shortages or Allied bombing of its airfields. It was killed by a paradox that lived inside it from the day Alexander Lippisch first drew it on paper. The faster it flew, the less it could do. And the proof was a single ratio or fraction so absurd that it turns 45 minutes of engineering, sacrifice, and ingenuity into a number that sounds like a punchline. 370 were built. The number that mattered was much smaller. You now know 2 things. You know what Alexander Lippisch built, and you know what it cost the men who flew it. But those 2 stories haven't met yet. The engineer's story ends in a quiet office in Iowa. The pilot's story ends on a grass airfield in Germany. The number that connects them is the number that makes the entire program either a tragedy or an obscenity, depending on how you count. 370 were built. 9 enemy aircraft were destroyed. 41 Me-163s manufactured for every single enemy plane shot down. A single competent pilot in a Bf-109 could exceed that total in a week. The painter's son, who saw Orville Wright fly at age 14, had spent 20 years building toward this ratio. Consider what the ratio consumed. Not just the aircraft's 370 airframes, each requiring specialized components, each assembled in factories that could have been building Bf-109s or Foch, Wolf 190s. Aircraft that actually worked. Aircraft with landing gear. The wings were subcontracted to furniture manufacturers. Men who normally built tables and cabinets shaped plywood and fabric into swept wing surfaces for a rocket plane. The production line moved from Messerschmitt to Clem to Junkers shuffled between companies because nobody wanted to be the one responsible for building it. The airframe itself was simple. Cheap, even. But everything around it, the specialized fuel infrastructure, the hazmat equipment, the dedicated airfields, the chemical supply chains, the protective suits, the 800-meter separation protocols was grotesquely expensive relative to what it produced. 9 kills. The industrial effort required to achieve those 9 kills could have equipped and supplied conventional fighter units that would have produced hundreds. And the man who proved it could work, who overcame the 3-second window and the impossible math, never lived to see the final number. Siegfried Schubert's total, 3 confirmed kills, 2 B-17s on August 24th, 1 additional. 3 enemy aircraft, a third of the entire program's output, destroyed by a single sergeant. He was a Feldwebel, not an officer, not a commissioned fighter pilot with an academy education and a family name, a non-commissioned officer. The top ace of the most advanced fighter aircraft in the world was an NCO with 3 kills. That was the ceiling the Me-163 imposed on human achievement. 3. No pilot would ever do better, because the machine wouldn't allow it. The 3-second window, the fuel limit, the landing system, the aircraft, imposed a maximum on what a human being could accomplish. And that maximum was 3. Shortly after his best day, Schubert climbed into the cockpit for a routine takeoff. The engine ignited. The aircraft began to roll. Then the engine failed. At 60 meters altitude, with a full fuel load, there is no recovery. The aircraft had no power. It had no altitude to trade for speed. It had no landing gear to absorb a forced landing. It tipped. The nose struck the grass. The fuselage folded forward, and the aircraft somersaulted a cartwheel of aluminum and plywood and 1,500 kilograms of hypergolic fuel, tumbling across the airfield. It had launched from seconds before. The fuel met. T-Stoff and C-Stoff, released from ruptured tanks, finding each other in the wreckage. The Comet's best pilot was not shot down by the enemy. He was not caught by a P-51 during his unpowered glide. He was killed on his own runway. On a routine takeoff, by the aircraft he was the best at flying. The plane rewarded its most skilled operator with exactly what it gave its least skilled, death by design. He was in his 20s. He had no idea he was carrying a third of the program's entire kill count. He had no idea there would only ever be 9. The engineers knew. They had always known. The 3-second firing window was not a surprise. It was a mathematical certainty that anyone with a slide rule could have calculated before the first prototype flew. And in the final months of the war, they tried one last desperate fix. They called it the Jagdfaust. SG-500. A battery of vertically firing 50-millimeter recoilless mortar tubes mounted in the wing roots. The concept was simple in a way that bordered on confession. If the pilot can't aim the guns because the aircraft is too fast, remove the need to aim entirely. Instead of attacking from behind the standard fighter approach, the Me-163 would fly beneath the bomber formation, close enough that the aircraft's shadow would fall across the belly of the bomber above. A photoelectric cell mounted on the Komet's upper fuselage would detect the shadow, the sudden darkening, as the aircraft passed beneath a 65,000-pound bomber, and automatically fire the mortars straight up, through the bomber's belly, without the pilot touching anything. The engineering solution to Too Fast to Aim was don't aim at all. Think about what this means. The engineers had built the fastest fighter in the world. They had spent 20 years refining the aerodynamics, the propulsion, the airframe. And the final answer to the weapon system's fundamental problem was a battery of dumb mortars triggered by a shadow detector. The Jagdfaust wasn't an improvement. It was an admission. The aircraft's original combat concept, high-speed gunnery, had been broken from the day Lippisch first drew a rocket-powered interceptor on paper. The fix conceded the paradox. It reportedly scored at least one kill. One kill from a weapon system designed to compensate for the failure of a weapon system designed to compensate for the limitations of an aircraft that was too fast to fight. But the Jagdfaust came too late. By the time it was deployed, the war was ending, fuel was gone, and the airfields were craters. The Me-163 program died not with a final battle, but with a quiet cessation aircraft pushed into hangars, drained of fuel, and abandoned. The rocket engine was a dead end. No subsequent operational military aircraft has ever used liquid rocket primary propulsion. The fuel system was a dead end. The dolly was a dead end. The belly skid was a dead end. 7.5 minutes of endurance was a dead end. But the wing survived. The delta wing, the triangular, tailless configuration that Alexander Lippisch spent the 1920s proving in silent gliders over the Wren Mountains, did not die with the Me-163. It did the opposite. It became the dominant aerodynamic configuration for supersonic flight worldwide. In 1946, the Americans captured one of Lippisch's last designs, the DM-1, a small glider model built for the coal-powered P-13A that never flew. The P-13A was the Exile project, the paper airplane, the punishment for losing a corporate war with Willie Messerschmitt. The Americans didn't care about the coal engine. They cared about the wing shape. They shipped the DM-1 to Langley. They tested it. They measured it. And then they gave the data to Convair. In 1948, Convair flew the XF-92A, the world's first jet-powered delta-wing aircraft. They consulted Lippisch directly. The man who had been exiled to Vienna, collected by paperclip and deposited in Ohio, was now advising American engineers on how to build the future of fighter aviation using principles he'd proven in gliders 2 decades earlier. The XF-92A led to the F-102 Delta Dagger. The F-102 led to the F-106 Delta Dart. Both became frontline Cold War interceptors for the United States Air Force aircraft designed to do exactly what the Me-163 was supposed to do, except with jet engines, proper landing gear, and fuel that didn't dissolve the pilot. The Delta Wing spread. Dassault adopted it for the Mirage, France's signature fighter, for 3 decades. The British built the Avro Vulcan, a nuclear bomber on a Delta platform. The Americans put it on the B-58 Hustler. And when engineers designed an aircraft to carry passengers across the Atlantic at twice the speed of sound, they chose a delta wing. Concorde. Lippisch's configuration, refined through 40 years of evolution, carrying champagne and businessmen at Mach 2. The Space Shuttle orbiter, the most complex flying machine ever built, re-entered the atmosphere on a delta wing. Lippisch didn't design any of these aircraft, but everyone uses the configuration he proved in gliders built from wood and canvas on a grass slope in the Wren Mountains. The shapes that other engineers called wrong became the shapes that defined supersonic flight. 370 Me-163s were built. They confirmed 9 kills. The weapon failed completely. But the aerodynamic principle behind the weapon succeeded completely. Both are true. Both are Alexander Lippisch's legacy. The catastrophe and the triumph sit in the same man, built from the same obsession, separated by nothing but the application. And by the time any of this was understood, by the time the Delta Wing was standard and the Komet was a museum piece, Lippisch was an old man in Iowa. Alexander Lippisch died on February 11, 1976, in Cedar Rapids, Iowa. He was 81 years old. He was working for Collins Radio, designing ground-effect vehicles, hovercraft, that skimmed the surface of water on the same aerodynamic principles he'd used to build gliders. 50 years earlier. He held more than 50 United States patents. His obituary mentioned contributions to Delta Wing aerodynamics and tailless aircraft design. It did not mention the pilots. In 1985, 9 years after his death, Lippisch was posthumously inducted into the International Air and Space Hall of Fame in San Diego. The citation honored his contributions to Delta Wing aerodynamics and tailless aircraft design. It did not mention the Me-163's casualty record. It did not mention Josef Pohs. It did not mention Siegfried Schubert. It did not mention the fuel that dissolved leather and skin and muscle with equal indifference. It honored principles. It did not honor consequences. He never publicly expressed remorse. He never acknowledged accountability for the men who died in an aircraft whose fundamental architecture, the decisions about weight, fuel placement, and landing were his. He had been removed from the project before it killed anyone. That was his defense, and it was technically accurate, and it explained nothing. Rudy Opitz, the chief test pilot who survived everything the Komet could do to a man, died in 2010. He was one of the last living links between the aircraft and the people who flew it. When he died, the Me-163 became entirely a museum object. A thing behind glass. A curiosity. You can see one in Munich, the Deutsches Museum, 3 miles from the hospital where Alexander Lippisch was born. A small, stubby aircraft behind glass, shorter than a modern SUV, with swept wings and no tail. The placard says Messerschmitt. It does not say Lippisch. It does not mention the pilots. It does not mention Cedar Rapids. A painter's son drew a watercolor of Orville Wright in flight over Tempelhof Field in 1909. He was 14. He kept that painting for the rest of his life. He spent 67 years trying to build a better plane. The one he built killed more of its own pilots than enemy aircraft. The painting survived. The pilots did not.